data shown on July 4 indicate that the newly found particle decays into a pair of other particles, photons, Ws, Zs, among others.
On the 4th of July, both Atlas and CMS presented their latest results for the Higgs search. And so Atlas looked in two different modes. They looked for the Higgs decaying to 2 Z bosons and 2 photons. And CMS looked at 5 different modes. They looked at 2 Z bosons, 2 W bosons, 2 photons, 2 taus, and 2 B quarks.
These data indicate that the spin of the new particle must be a whole number. The spin cannot be a half like the fermions. The data also rule out spin 1 for the new boson.
It cannot be 1 because 2 ones, 2 photons, don't make another 1. So these photons, they have what we call spin 1, but it could be spinning upwards or downwards. And if you combine an up one with a down one, you get 0, and that would be the Higgs boson. You could combine them so they're pointing in the same direction, and then it would have spin 2. And at the moment, we're trying very hard to figure out whether those 2 photons are like that or like that, and we don't know yet.
The Higgs would have to be spin 0. We said that in the big picture. Well, it has to be spin 0, otherwise it doesn't work. If it was spin 2, then the particle would not be the Higgs.
Now, the Higgs boson has this very special property. It has spin 0. So far, we've seen a whole bunch of bosons which have spin 1. But we've never, ever seen a boson with spin 0. Inside an atom, you've got a nucleus sitting in the middle, and that, if you like, sort of defines a direction. Okay, if you're outside the nucleus, you look in, and there's a direction where the nucleus is sitting. Now, the Higgs, we think, sits throughout all space. It's completely uniform, absolutely the same, absolutely everywhere. So it's not like, well, also the gravitational field. The gravitational field has as a source, like a planet, like the Earth or the Sun, okay? And it comes out of that source. But we think that the Higgs is everywhere in space, completely flat, completely the same in all directions.
So if it's spin 0, it's probably the Higgs, and that means our search has been successful. If it's spin 2, it's not the Higgs, and then we need some other explanation.
For the moment, we actually are not able to measure the spin with the data which has been shown on 4th of July.
This new particle that's been discovered is something that is different from anything we've ever seen before. There are some theories that propose that there could be spin 2 particles to be found at the LHC.
I have particles with spin 2. Probably one of the most interesting one would be the graviton.
We all expect that it's going to turn out to be a Higgs-like particle with spin 0.
So for Atlas and CMS, the next steps are going to be to take more data, to make these spin measurements, and also to measure the decays to the other particles. And that's sort of the stage we're at right now. We're getting closer and closer. We think it looks very much like the Higgs, but we're not sure yet. We need to get a little bit closer to be absolutely certain.
So I think it's a real experimental question. Is it 2 or is it 0?
All night, so spin round, round.